I'll be talking about how the bridges work, and bridges were developed when classic Ethernets were in use, so they are often shown using multi-drop cables. Bridges are the devices to which the stations and hubs are attached. For example, if you are using an Ethernet cable, the bridge will be known as the Ethernet switches. If there is more than one station or hub, the CSMA/CD protocol is used to send frames. In these examples, if a frame was to be sent from frame A to frame B, by the time the frame hits the bridge, it would be discarded because it had already sent to the destination. But if it was to be sent from frame A to like frame F, it would have to go down through the port 1, through the bridge to port 2, and then to port F. This example on the left is using multi-drop LANs, and this example on the left is using point-to-point stations. To bridge multi-drop LANs, a bridge is added as a new station on each multi-drop LAN. To bridge point-to-point LANs, the hubs are either connected or replaced with a bridge. You can connect different types of wires to a bridge, which makes it more useful for bridging LANs into different buildings, which would be this second example right here, where they would have one bridge in one building and another bridge in a different building, and they would use a long wire with this port in between. What happens inside the bridge? The bridge accepts every frame transmitted by the stations attached to each of its ports. The bridge must decide either to forward or discard each frame and find the output for each frame. A simple way to implement this scheme is to have a big hash table inside the bridge. The bridges use a flooding algorithm, also known as backward learning. The flooding algorithm outputs every incoming frame to all the ports except the sending port to find the destination port, and then save the destination in the hash table. So essentially, it'll send the frame and it'll check every other port or destination until it finds the correct one, and then it'll stop sending and it'll save the correct destination for the frame. Spanning tree bridges. To increase the reliability, redundant links can be used between bridges. To build a spanning tree, the bridges must run a distributed algorithm. Each bridge periodically broadcasts a configuration message out of its ports to its neighbors and processes the messages it receives from the other bridges. There is issues with bridges with two parallel links, which is this example where they have these different reductant links, and the two bridges, it will have two different copies of the same frame, and the bridges don't know that there is a copy. Therefore, it will create a loop, and an endless loop, which can cause issues. And this is a spanning tree that's connecting 5 different bridges. My question is, what is the flooding algorithm used by the bridges called or known as?